Hi everyone, it's a pleasure to be with you all today. My name is Cory Sago. I'm the CEO and co-founder of Amplitude Therapeutics. It's really fun to be in this room, especially to be around folks thinking about different type of delivery modalities. By training, I'm an LNP non-viral delivery person. It's actually funny, my first paper that I was ever given in my PhD was actually the Deverman et al. PHP.B paper saying, please try to make this but for nanoparticles. Am I supposed to have a clicker? All right. At Amplitude, we're really trying to think about some of the next generation platform technologies that might be necessary to create different types of genetic medicines. And I'd propose to you that non-viral genetic medicines are still so early in their story. So many conversations, we pretend like we've cracked a tissue, that we've solved a tissue, we've solved the liver, for instance, or we've solved mRNA vaccines. But I'm here standing in front of you, and the field has only dosed 3,000 people IV for a liver genetic disease. And the mRNA vaccines, though immensely powerful and beneficial, still show some very real limitations. But as a field, we've gotten excited, and we've moved on to bigger, more exciting applications, whether that's in different cell types, different payloads, different editors, more complex biology. And what I'd propose to you is if we actually want to work on the very exciting medicines on the right here, we as platform technologies need to get meaningfully better. And I'm talking orders of magnitude better from the potency, from the specificity, and from the safety. I think that there's three major toolboxes or applications that we can think about where that 100-fold better might come from. Now, I'm biased. These are the three that Amplitude is working on. So take that with a grain of salt. But I think if we get better delivery, as we've spoken about, if more of your dose that goes into a patient ends up where it needs to go for that therapeutic effect, that will only be beneficial. If you then maximize the potency of whatever you do get to those specific cell types, that will only be beneficial. And if you polish that off with specificity, whether that's turning on in the cell types necessary to interact with that disease and turn off in other cell types, that will only be beneficial. And so those are the three technology buckets that Amplitude's been working on. We're still a small team. We've been around for 3 years. We're over in the Lilly space, over in their Seaport Lilly Gateway Labs area. And what Amplitude is built on, it's funny being a delivery person, this company is actually founded around, and what we focused on first was that new type of expressing RNA. Basically, I came to my own conclusion that many others have as well, is that delivery will always be really hard. It's a very controversial statement within this room. But what if you had a type of payload that could compensate for that and work especially well and make copies of itself once you do get it to the cell type of interest? In order to do so, Amplitude has built a new type of amplifying RNA called trans-amplifying RNA. I won't go into all the details, but basically you can think about it as a mix between two existing clinically validated and clinically approved modified mRNAs, as in what Moderna and many others would do, as well as self-amplifying RNAs. We deliver two pieces of RNA to make this work. One is a replicase. You can just think about this as a copying machine. And we deliver a second piece of RNA. This encodes for your gene of interest, whether that's a vaccine antigen, something to encode for monoclonal antibody, a CAR, or an editor. And if you get both of those pieces of RNA into the cell, you get robust amplification, but that copying only occurs for about 24 hours. So we're able to get in, copy, and get out before the cells become so perturbed that they can't revert back to just being a turbocharged cell. We've shown that this trans-amplifying RNA can work across 6 different species. And the expression kinetics that we see are similar to what you'll see on the right, where here in mice, we're seeing at a matched total RNA dose level, more than 230-fold increased expression compared to a Moderna-like modified mRNA. But I wanted to focus more about delivery. In my past life, I built different LNP barcoding systems. If you didn't know what chemistry was going to get to a cell type, how could you throw hundreds of chemistries all into an animal, track where they distribute, and then try to back correlate what chemistries you wear? And while those technologies were undoubtedly powerful and led to some new chemistries and some breakthroughs in some cell types, they still showed some critical limitations. And their fundamental limitation was that at their core, they only measured biodistribution. That is, where did this nanoparticle accumulate? It didn't tell you if that nanoparticle worked in that cell type. And in the delivery field, we know that biodistribution is sufficient, but not necessary, but not, or whatever. Everything's complex, just like my words are right now. What we've done here at Amplitude is build a better type of barcoding system, one that really rewards and gives the maximal amount of signal to the nanoparticles that actually distribute to the cell, as well as endosomally escape an intact payload that can then translate and have copies made of itself. The way that we go about doing this is we put the barcodes, which are just 8 nucleotides, into our piece of RNA that gets amplified. And so what you might think is, what this allows is any nanoparticle that actually goes the full distance gets amplified between 100 to 1,000-fold. So based off of that platform, we're able to actually identify nanoparticles that work, and we're testing hundreds of LNPs all in the same animal. And what we see is a really strong correlation than when we test one nanoparticle in one cohort of animal. So we think the data are very predictive, including in cell types and tissues where the old biodistribution screens were not helpful. And then Amplitude started to put this in practice. We've tested a little over 1,000 LNPs in Vivo so far this year. We're increasing our throughput there. It then gets more powerful if we start to really combine this technology with kind of different computational design of experiment methods to help us optimize the formulation ratios of these nanoparticles. For folks who are not LNP folks in this room, LNPs are made out of 4 components. You can not only change the chemical structure of those components, but the ratios of those. So you gotta optimize it all if you wanna go and make the optimal LNP. So we can design and optimize the ratio at throughput in pools. And we have data that can show that we can take a locked, field-known ionizable lipid, retool its formulation ratio, and get over an order of magnitude increased potency from that. We're really working to industrialize this and kind of put it all into practice, novel chemistries, novel formulation ratios. And then some of our more recent data we've been able to show in humanized immune system mice that at a dose of 1 mg per kg, we're able to transfect with CAR over 70% of their CD8 positive T cells. This is certainly hot in the field. We think our approach is differentiated, and we're looking forward to continue to increase the potency with our approach. That's what I have, and I think that I'm perfectly at time. Thank you.